Hi everyone. Now we are going to discuss about transistor with voltage divider biasing circuit. Here we are considering NPN transistor. Here we are going to find the collector current IC and collector to emitter voltage VCE. Here there is a emitter and the here is the base and here is the collector, and here base is biased with voltage divider circuit with R2 and R4. Let us find the Thevenin's equivalent of this portion. To solve this, we need to simplify this circuit, and the simplified circuit is looks like this. As per this circuit, here 2.4k and 10k is parallel to each other. Here 2.4k is parallel with 10 kilo ohm. So equivalent resistance is given as RTH is equal to 2.4 kilo ohm into 10 kilo ohm divided by 2.4 kilo ohm plus 10 kilo ohm, which is equal to 1.94 kilo ohm. Similarly, we can find the Thevenin's equivalent voltage of this junction, that is equal to VTH. Here we have to find the Thevenin's equivalent voltage across this resistors 10k, so that VTH is given as 10k divided by 10k plus 2.4k into 10 volt, which is equal to 8.09 volt. Let us verify in this circuit. If I click here, we will get around 8.08622932 volt, and if we make round up on this, we will get around 8.09 volt. Here Thevenin's equivalent resistance of this base is much lesser than the 1 plus beta times of Re. Then we can make the approximate analysis. Here resistor R1 considers emitter resistance Re and resistor R3 considers collector resistance Rc. And as we know, the beta, the current gain of this transistor is 100. So that 1 plus beta times Re is equal to 101 into 1 kilo ohm, which is equal to 101 kilo ohm. So that we can conclude that Thevenin's equivalent resistance RTH is much lesser than compared to the Re. So we can make approximate analysis. And as we know, if we apply the voltage divider rule, we are getting Thevenin's equivalent voltage is 8.09 volt. So that equivalent circuit will be like this, because here we are considering the base voltage as 8.09 volt. So that emitter to base junction will be in forward bias condition. In the current transistor, we have emitter to base junction voltage will be 0.772 volt, and we can say that the voltage VE minus VB is equal to 0.7772 volt. So that VE is equal to VB plus 0.7772 volt, which is equal to 8.86 volt. After calculating the voltage VE, we can easily calculate the emitter current. So that emitter current IE is equal to 10 volt minus V divided by 1 kilo ohm, which is equal to 10 volt minus 8.86 volt divided by 1 kilo ohm. And when we simplify this, we will get 1.14 milliamps. And we can assume that collector current IC is approximately equal to IE, so that the same current will flow across the resistor 2.4 kilo ohm. That means IC is equal to 1.14 milliamps. Now we can easily find the collector voltage, which is VC is equal to 2.4k times 1.14 milliamps, which is equal to 2.74 volt. And we know that VE is equal to 8.86 volt, so that we can calculate VC. VC equal to VC minus V, which is equal to 2.74 volt minus 8.86 volt, which is equal to minus 6.12 volt. In this way, we can find the voltage across collector to emitter junction and the collector current IC. So let us simulate the circuit. As we calculated, Thevenin's equivalent voltage across this junction will be 8.09 volt, and similarly voltage across this node will be 8.86 volt, and similarly voltage across VC will be 2.7 volt, and collector current which is equal to around 1.14 milliamps. Difference between the collector to emitter voltage will be 6.16 volt. Hope you are able to understand how we can calculate voltage across the collector to emitter when we are used voltage divider as a biasing voltage of base. Hope you are able to understand this circuit. Thank you. Thank you for the watching.